Okay guys, this one is a little bit wonky. There's a lot of different material that we're going to cover in 1.6 and most of it is things that we've done before, so we're just going to do some quick revisiting and then really focus in on some questions that might be difficult or like things you might see on an SAT that are particular to this type of subject, so we're going to look at those. So 4 goals: rearranging formulas to highlight a variable, quick linear equation review, distance formula and midpoint, and then just some situations in which either using a graphing calculator or a substitution or elimination is the best method for solving a system of equations. So we'll look at some different options for that one. So we're going to look at rearranging formulas here. We're going to look at just some tricky ones, things that kids tend to mess up. So this one here, the reason kids tend to mess this one up is because the variable we're looking to isolate is in the denominator and it's under a radical, so quite a bit to think about here. So this one is under the radical. First thing we're going to do is have to eliminate that so that we can access this stuff that's under here. So q squared equals a over tp, because when you square a radical it cancels it out. Uh-oh, our term's still in the denominator. That's a real problem. One of the tricks we see people do sometimes is put this over 1 and cross multiply. I like to go ahead and write out what I'm multiplying on both sides because it seems to make more sense in terms of what I'm actually doing here. So I'm going to leave this a on this side and then t minus p quantity times q. Well, I've got to get to this p here. So I'm not going to be able to get to this p until I distribute through this q squared. So we'll go ahead and distribute through the q squared. So q squared t minus q squared p equals a. Well, still looking to get him by himself, so let's move this to the other side by subtracting it off. So negative q squared p equals a minus, so we have to subtract this positive value to get it out of here. Alright, is my p by itself yet? No, it's still attached to negative q squared by multiplication, and when we are solving for things, we're always using inverse operations to remove adding or subtracting, multiplying, dividing. We're using the opposite operation to make it go away. So the opposite of multiplying is to divide out whatever that number is. So negative q squared over negative q squared is 1, and I'm left with p. So if I wanted to solve for p, I would say that p is worth a minus q squared t all over negative q squared. Somebody in some of the problems last week, they didn't like having a negative in the denominator, so I'll change this to positive and these to their opposite values as well. So we'll just make everything its opposite value. Here's one that kids struggle with because it has a p here, and a p here, and they're all connected to different variables. So what probably happened in this case when it got to be this as a multiplied out solution was that we had p timesing a bunch of things to begin with. So let's undo all of that distribution of that p by factoring. So pulling out this p on this side gives us r minus t quantity equals p minus s. Well, I still have p's here and p's here, so let's get all of those p's to the same side. So p times the quantity r minus t minus p subtracted over equals negative s. Well, now what? I have a p on this one and a p on this one, so I would bet that there had been like a double distribution thing here. It had been distributed at this level, but it had also been distributed even above that. So I'm going to remind myself that there is a 1 on this p, which allows me to factor out a p from everything on the left-hand side of the equation. I'm going to factor that p out. So p times what gave us p times rt? Well, p times r minus t, And then p times what gave us minus p? Negative 1 for this side equals negative s. And now I'm almost there. I almost have p by itself. I have p times this whole quantity. So if I need to get rid of a whole quantity, I'm just going to divide it all at once as r minus t minus 1. And then same thing over here, r minus t minus 1. And that whole thing will cancel with this whole thing. So in this case, p in the end was worth negative s all over r minus t minus 1. So kind of a weird one, but common errors found here and common struggles in this kind of problem. One more here. We're going to solve for big R. Woo. So I've got an R here and an R here. So that's weird. Well, first thing I like to do when I have problems like this is get whatever's going on in the denominator out of the denominator, because I have to be able to access it, and I can't do that until it's out of the denominator. I'm going to multiply both sides by that quantity to make my life easier. Whoops, I have to write tiny on this side. So r plus r times I equals, quantity cancels with quantity, n r. Well, cool, but I still have r's on this side and big R here and a little r here, and it's all multiplying by that I. And I can't get to this r until I distribute that, so I have to either divide that out, but then I have this guy being divided, so I'm kind of stuck here. I'm going to have to move forward at this point. I'm going to do that by distributing this I. So I times r plus I times little r equals n times big R. Well, now I have r and r, so let's try to get all those to one side of the equation and then everything else on the other. So IR equals n big R minus I big R. Whenever I see it like this, I can pull it out, factor that out, make my life easy. IR equals factored out R times n minus I. Cool. Almost there. I have R times a quantity. Let's divide out that quantity. And anything I do to one side, I do to the other. All right. R is by itself at this point, right? So R is worth I little r over n minus I.